Hello and welcome to Vision Economics Academy. Today I'll be starting with section A of class 11 economics, that is statistics for economics. I'm starting with unit 3 and chapter number 8, that is measures of central tendency. Right? So, what is measures of central tendency? Measures of central tendency is a single value which is used to represent an entire set of data. So, there are a set of data, and through a basic calculation, through various methods, you get one particular answer. And that particular answer represents the entire set of data. So it's a single value which is used to represent an entire set of data. For example, average height of students in a class represents height of all students in the class. Suppose there are 30 students in the class, and if we note down or measure the height of each student, right, and take the average of the student's height, then there will come a single value which would represent the height of all the students of the class, right? So it is also called average or measure of locations, right? There are different names given to it. So it's also called average or measures of location. So types of averages. There are three types of averages. First is mathematical averages, then it is positional averages, then there is commercial averages. We will be covering arithmetic mean from mathematical averages, median and mode from positional averages. Okay, so what arithmetic mean actually is? It's simple average, right? It's sum of the values of all observations divided by number of observations. So most common and simplest measure of central tendency is the arithmetic mean. So arithmetic mean is the most common and simplest measure of central tendency, is just finding the average. It's denoted by x bar. It is used when all the items of the series are to be given equal importance. So, see, mainly it's helpful, right, when there aren't many extreme values and where we want to include all the items in the series. Okay, when each of the items in the series are given equal importance, but mind you, mean is affected by extreme values. So the items in the distribution should not be so much varying, right? Because mean is affected by the extreme values. Therefore, we know that when we are calculating arithmetic mean, then each item, all the items of the series are given equal importance. All right. Then kinds of arithmetic mean. There are two types of arithmetic mean that we will be covering. One is simple arithmetic mean. Second is weighted arithmetic mean. Okay, we will be covering both. Then we need to identify series. So there are three series: individual series, discrete series and continuous series. So our first step in solving the numericals over here is to identify as to which series it belongs to, right? So first our job is to identify the series. Okay, and it's very easy to identify. First, the individual series where items are listed singly is the individual series, where there is details about each individual, where each items are listed in a single way, in single manner, that is individual series. Suppose there are 5 students, and the marks scored by 5 students are as follows: A 85, B 60, C 50, D 75, E 55. So this particular series is the individual series. Now the discrete series, also known as frequency array, is the values of variables that shows repetitions. Okay, discrete series is the values of the variable that shows repetitions. There is some kind of exactness over here. I'll give you the example after I finish with what continuous series is. So continuous series is the value of variable that are grouped in various class intervals. So in a very layman manner, you can identify continuous series through class intervals and frequency. All right. So for example, the discrete series example is marks, that is 20, 30, 40, 50, 60. And there is, as I've said, there is some exactness, right? So there are frequency over here. That means 8 of the students have got 20 marks exactly. 12 of the students have got 30 marks. 20 of the students have got 40, and there are 10 students who have got 50 and 6 students who have got 60. So if the distribution, if the data is given in this form, that is a discrete series. Then the other one is continuous series, where you have the class interval and there is frequency, right? Now let us see the formula for each of the series: individual, discrete and continuous series. So there are 3 methods to solve each of these series, and the formula for each is as follows. So sometimes the question would not ask you directly as to which method to use, then it's your discretion. Most of us do use direct method because it's the simplest one, right? But you have your own discretion, whichever method you want to use. Sometimes the question may come in such a manner that they will ask you to solve by all the 3 methods, right? So we need to learn all the 3 methods for all the 3 series. All right. So these 9 formulas you need to remember very well. X bar equals to summation x by n is the formula for individual series, direct method. For shortcut method, it is x bar equals to a plus summation d by n. Now what is a? A is assumed mean. So a is the assumed mean. D over here is deviations of variable from assumed mean, that is D is nothing but x minus a, and summation D is the sum of deviations of variable from the assumed mean. Okay, so addition of this would give us summation D, right? So D, I repeat, is deviations of variable from assumed mean, and summation D is the sum of deviations of variable from the assumed mean. Now step deviation method, x bar equals to a plus summation d dash by n into c. Now what is d dash? D dash is x minus a by c. Alright. So what is c? C is the common factor. C is the common factor. Okay. Now summation d dash is the sum of step deviations, right? Sum of step deviations. So what you need to know is individual series direct method. The formula is simple, that is summation x by n. Summation x is nothing but summation of values of a variable x. So summation of variable x is summation x, and n is the number of observation. Whereas in shortcut method, x bar equals to a plus summation d by n, where a is the assumed mean, d is the deviations of variables from assumed mean, and summation d is the sum of deviations of variables from assumed mean. Now discrete series, the formula is x bar equals to summation of fx by summation f. Now fx is nothing but the product of frequency into variables, and summation of fx is the sum of the product of frequency into variables, and summation f is the total of frequency. Summation f is nothing but total of frequency. In shortcut method, the formula is x bar equals to a plus summation fd, literal difference only, by summation f. Alright. Then in step deviation method, it is x bar equals to a plus summation f d dash by summation f into c. Okay. So fd is nothing but the product of deviations d and respective frequency, and summation of fd is the sum of the product of deviations d and the respective frequencies. Then comes x bar. X bar is a plus summation f d dash. Again, f into d dash is the d dash is x minus a by c, right? So it's the product of step deviation and respective frequency. F d dash is the product of deviation, step deviation and respective frequency, and sum of it is summation f d dash, right? And c is the common factor, as we all know. Now in continuous series, x bar equals to summation fm by summation f, whereas m here is the midpoint, right? Then summation fm we have. So fm is the product of frequency and midpoints. Okay. Then summation fm is the summation of fm, addition of all the product of frequency and midpoint. Then comes shortcut method, x bar equals to a plus summation fd by summation f. Now you can see the formula is similar, right? Formula is similar, but there is a difference in the way you get deviation. Here d is m minus a. Okay, so there is a difference. It's not x minus a, m minus a. So here d is brought through the difference between midpoint and the assumed mean. And in the same way, the step deviation method, x bar equals to a plus summation f d dash by summation f into c. So here also d dash is nothing but m minus a by c. Alright. So these are the 9 formulas that is used when we are calculating arithmetic mean from different series through different methods. Alright. So as we practice, I suggest you, whenever you are solving the numericals, to always write the formula so that it may be repeated many times and your and the formula gets ingrained in your mind, so that it will be easier for you to uh, solve it and remember during the exams. All right, so this much for this episode. In the next episode I will be covering the unsolved practicals from the Sandeep Garg book, right? So in the next class, in the next episode, I would be covering the unsolved practicals of this chapter from the book of Sandeep Garg. Till then, please stay tuned. If you like the channel, please hit the like and subscribe it and share it among your friends, and it encourages me, it motivates me to further work hard and present you with easy solutions and understanding and explanation of +2 economics